Hello everyone, my name is Yann Baehr. I'm a PhD student at CNRM under the supervision of Jean-Christophe. My PhD is about wildfire risk and the use of artificial intelligence for wildfire risk. I'm a second year PhD student and I will present to you my work at the first year of my first year. The title of the presentation is Use of Artificial Intelligence to Monitor Live Fuel Moisture Content across France. So we have several questions, the questions that we had in the beginning of the thesis. So I just changed the question to fit to live fuel moisture content, but the first question that we had is if we will be able to predict the fuel characteristics by using the land surface model ISBA that Jean-Christophe talked about. So we want to know if a neural network is able to generalize the live fuel moisture content across different sites or year and generalize over the whole territory. Then we will see some limitation and how to add this information into the operational aspects. So I will present to you the dataset of LFMC and the model a little bit, my model, and then some results. So live fuel moisture content is the same protocol that I don't talk about yesterday. So it's a dataset created by the ONF, which is le réseau hydrique, so historically around the Mediterranean Sea. And since 2020, the ONF want to extend the geographical cartography of LFMC. So here we have the map of 2023, so we can see that we have an extension over the west coast. And in 2024, we have more sites over the north of France, something like 30 new sites. So it will be interesting to challenge the model to see if it will be able to generalize when I will test my model over the year 2024. It's important to say that this is the equation that Adam presented to us yesterday, but this equation is the one we will see in the literature, but the operational services and the ONF use the same equation, except that we divide by the fresh mass. So the model will be calibrated over the LFMC fresh, but I will convert the value to LFMC dry, this version of LFMC for the presentation. So when I will talk about LFMC, it will be this equation, and if I talk about LFMC fresh, it's the operational value. So LFMC is very interesting for fire ignition, fire propagation, but also fire severity, and we will talk about it a little bit later. So the model that I will use is the ISBA LDAS-AROM that Jean-Christophe talked about earlier. So yeah, it's the same principle that Jean-Christophe already talked about, so I will not talk about that. I just want to skip and talk about the inputs that I will use and the information that we have into the ISBA LDAS-AROM. So we can have information about the leaf area index, but also the temperature and the soil water index at different depths in the ground for a different bottom grid, and also biomass with structural and leaf biomass. So we have, like I said, different depths from the surface to 12 meters and several patches, 12. It will correspond to the nature of the point of grid, such as bare soil or boreal forests, things like that. And because of the dataset of the ONF and the species that are studied to create the LFMC, I will use the patch number 4, which is temperate deciduous forest. And yes, that's it. So now I will talk about the inputs. So I already presented to you what I will call the dynamics inputs, which are the soil water index, the leaf biomass, and the sum of leaf and structural biomass, but also the LAI and the normalized LAI by the wilting point and field component, capacity, thank you. And we'll also use static inputs such as fraction of clay, sand, slope, complex topography, and so on. Those, and the day of the year, I will use it, and I will encode it with a sine and cosine function to avoid discontinuity, but we will see that later. This information is used as an input of surface, so everything is hidden in the ISBA model. Then I will use a library, which is a library which is Optuna, that will help me to select the variables, the last variables, the remaining variables. So I just run the code, and it chooses those variables for me. Around I did around 15K combination to find those. And for the train data set, because because I'm using the AROM model, I have to start from 2017 until now. So I will train over the years 2017 to 2023, then test on 2024. And I will use 70% of each year at the train set, in the train set, and 30% in the validation set. That allow me to put every years in the validation and train to use anomaly, to use years that are considered as anomaly, such as 2022, which was a very particular year. So now I will talk a little bit about the models. So like I said, I will use a neural network for estimate the value of LFMC. So it was a long way to go to create this model. So here it is. I will use the dynamic inputs as a main input, and then the static input inside the model to force the interaction between the dynamics and statics inputs during all the process in the model. And because we want to add the model into ISBA, which is coded in Fortran, I add a small amount of layer that was able to be used, such as the fully connected layers, but also batch normalization and dropout layers. So with this architecture here, it would be easy for me to add it. I mean, easy. It would be challenging, but it will be easier for me to add it into the Fortran code. And I will propose this model with a latent dimension of 4, which has approximately 7K trainable parameters. Okay, so this is just the list of scores that I will be using to estimate the performance of the model. So the RMSE, the Pearson correlation, but also this Nash-Sutcliffe model efficiency coefficient, which is a determination coefficient to see how the model fits to the observation, and the Klein-Gupta efficiency to see if I have a temporal shift or not. So here is the performance of the model of the LFMC fresh, so the operational one. So we can see that we have, I mean, the score are fine with a small RMSE, a nice correlation, and the NSE, which is close to 65, sorry. And then I will convert the value to LFMC, I mean the standard LFMC, the literature one. So here is the result. And I was very happy to hear the presentation of Adam yesterday, because I found out that I have approximately the same tail here and same expansion of the high value of my LFMC. So I like the justification that he gave yesterday. But yeah, so here is the results of the first performances. So now I will cross-validate the model with 3 scenarios. So the first is forward chaining. So I will train over a year to estimate the year after, then the first two to the third, and so on, to see if adding information will help me to gain some performance or things like that, or to see if, for example, 2022 has an impact. Then I will perform the live one year out, so I will train over every year except one and see how it will evolve around the years. And I will do the same thing with live one site out, but I will extract 3 random sites and estimate them. And I choose to take 3 random sites who have a nice statistics of my scores, because sometimes I just have one value for one site, so I don't want to do something like that. So here are the summary with the scores, and for this figure, the A is it will be the forward chaining scenario, and the B it's live 1 year out. So we can see for the forward chaining that the score went up as soon as you had information, except that you have one gap here in 2020 and another one in 2022. So 2020, like I said earlier, it was the first time that réseau hydrique went outside the historical réseau. So that allowed me to say that maybe at this point here, because I was training over a known region, it was a little bit of, what is it called again? Surapprentissage. Yeah, overfitting. Thank you. And for 2022, so it was the first time that we had such information, such an anomaly. So that makes sense for me if we had such scores. I mean, the scores that went down. And when we look at the live 1 year out, we have the same behavior in 2022 as well. So now I will go a little bit in detail for the live 1 site out. So I choose three scenarios with les Adrèches, la forêt de la Coubre, et la chapelle Moulière. So les Adrèches is a site which is into the historical réseau hydrique, so it's well covered in time and in space. So when I take out this station and I train over all the sites and I look at the performance, I do have a pretty good performance on this site, but I mean it was well covered, spatially and temporally, so it makes sense. For la forêt de la Coubre, which is a new site of the réseau, the extended version, it's in the north part of Les Landes, which is in the west coast of France. Even if it's not well temporarily covered, it's an area which is well spatially covered since, so we have a good performance anyway. But when we took La Chapelle Moulière, which is something totally new in the middle of nowhere, and we have no information around it, then we had, not a good correlation on this site. But when we look at every new site of 2024, some of the new sites are well represented by the model, but some others are just not that good represented. That means that I still need information about the areas, or I need to feed the model with the new site that I have in 2024. So I would like to have the data from 2025 to feed the model that I have with 2034 to see how the performance goes. So now I want to speak a little bit about the feature importance. So something that we did is to neutralize the variables one by one to see the impact on the results. And so that's what I did. And I normalized all the variables to be able to compare it. I just reverse the correlation and the KGE to have the same ways of evaluation. And the thing that we can see here is bigger your quadrilateral is, then the greater impact the variable will have on the model. So the first is the leaf area index normalized by the field capacity, which has a big impact on my model. So, and even when I do the Shapley importance variables, then I can have this variable on top of that. So it's really important for the model to keep this information. And then in the second place, we have the SWI, which is a soil water index at the third layer. So it's 10 centimeter dips, something like that, if I'm correct. And then we can have the day of the year, which has an impact on the error and also the bias and the correlation and so on. But we can see that the sand and the fraction of sand and slope does not have a big impact, and this is something that I can find into the Shapley importances values. So maybe I can just extract them, but I know that if I do so, I will lose some information about the spatialization. But so this is interesting to see, but I don't have to. I don't have to extract all the value that does not have a big impact, because I still have an impact on the model. So now that I have a model, and I wanted to play a little bit with it. So I just, I just took a date around 2022 and the same in 2023, and then I applied the model over those grids. And so I have many things to say about those. The first thing is I was really happy to have such maps, because the model was able to produce something and not just do an average value over the areas that it does not know. So I was a little bit surprised, but in the good way. And we can have some geographical areas that make sense as well, such as mountain chains, or even the river, or And the other point is that even if I'm using the day of the year, and it's the same day, I do not have the same maps over the year, so that's encouraging. And we can see how 2022 was a dry year. Okay. So now that I have my maps, I wanted to see how the model was able to give me the same informations, or how the model will react from a run to another run. So I did 100 runs to see how the value will change from a run to another. So I computed the standard deviation to see the evolution of those. And we can see that over the metropolitan France, then we have a value between 5% to 0%, so it's pretty good, except for the mountain chains, which are the point of grid where we have a low fraction of the patch number 4, so it can be hard for the model to see what's going on at this place. And here over the Netherlands, but it's not something that I studied, so I don't know. So now that, because I'm using the home, I'm able to predict the map for every day, every year since 2017. So I took the average case and once again to see the evolution of FMC since 2017 until now on the daily basis to see the evolution. And we can see that because of the encoded version of the day of the year, I don't have the discontinuity between the first day of the year and the last day of the year. So it was, I'm very happy with this kind of result, even if I don't have any values in winter, so I'm not able to certify the values that I have now, but I mean, that makes sense with what I can see in the literature about the behavior of LFMC. So now that I have a value, an estimated value of LFMC, I wanted to know about the fire occurrence and if I'm able to find the same behavior as I saw in the literature about how the LFMC can go down and then fire ignition started. So I went to the BEDIF database to have information about all the recorded fire events in 2022, in summer 2022. So here all the orange dots are the ignition points, the fire ignition recorded over France. So I took all the values at the cantonal level of each starting point, and I evaluate the evolution of LFMC 10 days before the ignition point after 5 days to see the evolution of this value. And we can see the average value went from 100% to a little bit less than 90%. And a threshold that I saw in the literature is 100%. The LFMC below 100% is a risk. We have a risk of fire ignition. So, I mean, even if my model is not as correct as we would like to have, we have a good behavior of fire ignition from the studied points. And so like Jean-Christophe told us earlier, since July, I don't remember, no, June 2024, I think, the model was operationally launched, tested at least. So every day since we have a map of LFMC fresh that is produced, and the map of today will be available in 10 minutes. And in the meantime, we have la météo des forêts so we can, I will not say compare it, but here we have my maps and here la météo des forêts. But this map to be produced use meteorological variables that I don't use. So, but anyway, here this period was very dry with no wind and very dry and very hot. So we are able to compare it a little bit, and I'm very happy to see that we have similar pattern from this map to this map for a dry day, at least for a dry period. Yeah, we talked about reboot yesterday, so it's my turn to talk about reboot. So just after the ignition of the fire, I had the idea to see the behavior of my model on reboot. So here we have the evolution of LFMC, of the values of LFMC exactly on reboot, and here the graphic evolution of the region. And the ignition date is here, and here is the end of the fire event. And we can see that we have, the value of LFMC was very low, and according to this map, we had a region that was prone to a big fire event. So, I was not happy with the event, but I was happy about the results. And so now I want to have more information about the LFMC over France and more data about it. So I just try to combine my model uncertainty at the distance of existing sites to see where I would like to have a new site from the ONF. So I use K-means clustering to have to classify the map, to have to know where I can deploy, where I would like to have a station to be deployed. So the conclusions, what time is it? Yeah. The conclusion, so can live fuel moisture be predicted by a land surface model. So for now, yeah, I was able to develop a model and use just the land surface model to have an approximation. I don't did any integration of satellite observation yet, but we would like to add information later. Is a neural network able to generalize? So we can see that over the years and existing sites, yes, it kind of works. But when we go far from the existing sites, we have trouble we could have trouble to estimate the value of LFMC depending on the soil or the condition, even the species. So the limitation are species, but also the anomaly that we can have from a year to another. And what about the operational aspect? And, I don't have information yet about the operational or the ONF, so I can't respond yet, even if when I had trouble with the automatic chain to give information to the ONF, I had an email like, give me the map, we want the map. So maybe the ONF was interested in my project anyway. So what next? We would like to use the LDAS world to estimate the value of LFMC over France, outside of France, sorry, using the LFMC globe to validate the results, or at least to calibrate the model. Then we want to compare with some satellite-based vegetation water content, or use the LDAS Safran to see if there is any change with the actual model, compare with the operational wildfire, or use them to feed the neural network, and see other things that temperate broadleaf, such as grassland or crops. So yeah, and that was yesterday's map. So thanks for